In order to find the support reactions at the ball support at point B and C and a ball and socket joint at point A for a uniformly loaded plate as shown in the figure, we can start by developing our free body diagram. Now for the free body diagram, first of all, we have to identify our reference point such as X, Y, and Z axis, and next list down all the external loads acting on the plate as well as the support reactions. So to start, for a ball and socket joint, we have three support reactions going along the X, Y, and Z axis as the motion is restricted along X, Y, and Z axis for a ball and socket joint and the rotation is allowed. Next, for the ball supports at point P and C, we have just one support reaction acting vertically upward as the motion is restricted along the Z axis. Next, let's go ahead and identify the position of these support reactions because we will need these distances to calculate the moment while we are writing our equilibrium equation. Afterwards, we have an external load that is uniformly distributed on the plate. Let's go ahead and convert it into a point load by multiplying that distributed load with the area of the plate that is coming as 16 pound. Now this point load will act at the centroid of the plate, and the dimensions we can list them down on the free body diagram as well. Once we have all the external loads and support reactions, let's go ahead and apply our equilibrium condition. So for a 3D system, we have 6 equilibrium condition. We can start by summation of forces along the x-axis equals to 0 and summation of forces along the y-axis equals to 0. Since we don't have any other force acting along the x and y axis except ax and ay, the value of them is equals to 0. Next, we can write the summation of moment about the x-axis equals to 0, taking counterclockwise as positive, since it's only going to give us two unknowns, as ax, ay, and az won't create the moment about the x-axis at they'll pass through the axis itself, whereas cz will create our counterclockwise moment with a moment arm of 1 feet, whereas BZ also going to create a counterclockwise moment having a moment arm of 2. Finally, our point load of 16 pound is going to create our clockwise moment with respect to x-axis. Next, we can go ahead and write summation of moment along the y-axis equals to 0. Similarly, ax, ay, and az won't create moment. Only cz, bz, and 16-pound force is going to create the moment. Simplifying these two expressions, we can calculate the value of cz and bz that is coming as 5.33 pounds. Now, once we have the ball support reactions at B and C, we can go ahead and identify our AZ value. To do that, we can go ahead and write our summation of forces acting along the z-axis equals to 0. In this case, AZ is pointing upward, that's why it's taken as positive. Similarly, our BZ and CZ is acting in the upward direction, whereas 16 pound is going downward. Simplifying, we get the value of AZ as 5.33 pound as well.